Streaming. And we're live. So this is these are the same rules from last year for Lewis dot diagrams. Last year I only taught you these particular rules because these work in almost every case you're going to get in, and I find if I teach the other method first, students want to use that for everything because the other method's way easier. So I'm going to show you both the easy method, because now there's some times where actually using these rules doesn't help you. And I'm going to show you the method with this where they will help you. Yes? Yeah. So we're going to continue. Now, we did last day for single elements, and I believe, yeah, we did, and charged. So we did it with a charge where we put brackets around it. So the brackets just mean all these electrons are inside, and this entire thing is a -1 charge. We didn't need brackets around sodium because it didn't have any electrons, so it's just like, it's just the sodium. Okay? It does, but we're not, for Lewis, we only write down the valence electrons. And sodium doesn't have any valence electrons because it gave them up. Or at least for Lewis dot diagram purposes. And as you finish getting that down, I will take attendance. Alexander, Anton, you still have to write the test tonight. Okay, it's in the library, and you take it at the testing center. Was there anybody else in this class? And when you write the test, hand in your Hebden at the same time. Okay? And I think that was it from this class. Just hand in the Hebden with the test to whoever's there. Just tell them I want it all. Or you can hand it in at receptions before you write the test. Just hand it at reception, say, please put this in Mr. Neufeld's box. If you ever hand in anything at the reception for me, in case you haven't done that before, make sure, and this works for any teacher, you can hand things in at reception. Just make sure your name is on it and my name is on it. Because if you just hand it with only your name and then they look at it, they'll go, oh, it's chemistry, and they'll probably give it to Mr. Snow or some other random teacher. Cahalan, there, Donald, here, Evan, Henry, put away the laptop, Hyundai, Jacob, Joffrey, I do not see Joffrey. Pardon? Yeah. No. Jonathan. He hasn't arrived yet either. I should know that. I'm his house parent, Joshua. Kate. I saw Kate. There she is. Keith. Martin. And Ned. And Richard. And Sasha. And Will. No Will. Excellent. Okay. If you had me last year as a teacher, this is the method we would have used. Don't know if I used more or less words. Also, a reminder, you should not be writing everything down verbatim, word for word. You should write it down in a format that's summarized that you can understand. So this would be my version of that format. Number 1, count all val electrons. If it's +1, minus electrons. If it's -1, plus electrons, because that makes sense to me. 2, put the center in the center. Bond, 2 electrons per bond. 3, put on the electrons, outside to inside until gone, pairs only. 4 is when you start adding double bonds. If your central atom has too few electrons, you just start giving it bonds from the outer electrons that you put on the outer atoms. We're going to do oxygen both methods, the easy method and the formal method with these rules. A few definitions. Lone pairs are non-bonding of valence electrons, so those usually are the dots on the outside, unless you're German, in which case you make them lines. Also the octet rule. Each atom in families 14 to 17, and 14 to 17 isn't that many families. And they're only at the top. There's actually very few atoms that actually obey the octet rule. But there's very few types of atoms. Those types of atoms are very common atoms. And so a lot of the structures we actually do tend to conform to the octet rule, because those are the atoms we're dealing with. These are the atoms of life, carbon, nitrogen, oxygen, those types of things are all going to obey the octet rule. One exception we already know about is hydrogen only wants 2 electrons, not 8. Hydrogen only has s orbitals, so it only fits 2. All the other ones have both their s and their p, so then they can go up to 8. Now, is there anybody who needs me, because I went through that very quickly, anybody need me to scroll back up? Or did I time that well? How far up? Anton, how far up? Okay, Ned, go. Yep. No. You put it, well, I'll show you how this works. It'll make a lot more sense in context. So I'm having you write these rules down so that you look at them as you go through. Because I'll say, okay, you did up to step 2. What's next? And then the student will invariably say, I don't know. And I'm like, look at the next words. And then they do that. So when you the very first thing you did, well, not the very first thing. The second thing you did is you put a central atom down and bonded it to its outer atoms. It's those atoms. Not just random ones off the periodic table, because that'd be a little strange. Good for number 2 there, Anton? Okay. Ned and Joshua, what are you doing? Okay. That's okay, though. It's okay. So, on here, number 1, we're going to count the valence electrons. And I want you to do this as a formal process. You put all the valence electrons at the top, and as you do these steps, you minus the electrons at every step. So I can see your work. And it helps you keep track of all the steps to make sure you don't skip out on something. Then you put the one atom that seems to be the central atom. It's usually only of one type. There'll be some exceptions as we're doing these examples. You put it in the center, and you put all the other atoms around it. Bond each with 1 bond, and then from your valence electrons, you're going to minus 2 electrons per bond. Once you've done that, you just take the electrons you have left over and put them on the outer atoms until you just run out, until they have their octet, if they need an octet. If you have electrons left over after that, they all have an octet, you just put them all on the central atom, no matter how many there are, in pairs. Minus them out, then you should be down to 0 if nothing else. If before you got to that stage, you ran out of electrons and the central atom doesn't have an octet, that's when you start grabbing some of those lone pairs off of the outer atoms and making bonds with the central one until they have an octet. Now the first one is probably the favorite one. It's the most common one for Lewis dot diagrams. And I'm going to do it both with these rules and without these rules. Anybody still writing this down? Okay, what I would like you to hear for this first part, don't follow those rules. I want you to draw the Lewis dot diagram separately for hydrogen, twice, because you have 2 hydrogens, and oxygen. So just draw the individual Lewis dot diagrams for hydrogen and oxygen. And just to start off, because it apparently on the break some people forgot, I'm going to say random. Ned, how many valence electrons does boron have? No. 3. Excellent. Alexander, how many valence electrons does sulfur have? Excellent. And Ned, it called you twice. How many valence electrons does oxygen have? 6. Richard, how many valence electrons does neon have? 8. How many valence electrons, Caholen, does silicon have? 4. We seem to be good now. Maybe one more for luck. Henry, how many valence electrons does oxygen have? 6. So remembering how to count electrons, give me the individual Lewis dot diagrams for hydrogen, 2 of them, and oxygen. And then I'm going to ask some people what those should look like. Evan, what does the Lewis dot diagram for hydrogen look like? Oh, I will wait. Ned, what's your question? Oh, you're doing it already. Okay, yeah. Go. Yeah. Yeah. That's actually what it looks like. Yeah. Well, since you already started, what does the Lewis dot diagram for hydrogen look like? It has a dot. Excellent. And then Evan, what does oxygen look like? How are they arranged, though? How many pairs? Excellent. Yeah, 2 pairs and 2 lones. So if you remember, you have 6 valence electrons. You go 1, 2, 3, 4, 5, 6, and then we get oxygen. Now, without using all the rules I just made you write down, when you're looking at how to do a Lewis dot diagram, sometimes you do it what's called inspection. You just look at it and go, electrons that are paired up like to stay paired up. Electrons that are free like to be bonded. So the hydrogen here that doesn't have a paired electron, where's it going to go? Yes? To an unbonded electron. So it just flies on over. It bonds there. And then that becomes a bond. And you take those 2 away. Let me go like this. And see, oh, those unbonded ones become bonded. And then you do the same thing with this one. Except we have to, change where the electron is. But now they can, oops. Drag it all over. Now they can bond. And this is called inspection because you just look at it and go, oh, that's where those go. And that works in a lot of cases. You can just look at it and go, this is what water looks like. We've got our unbonded pairs, and we just did it by getting the individual ones like we did last day. I don't want you to do this method for the next few, but I want you to keep it in mind because some later ones, this will be easier to do than the other method, but they're both useful. So Put that one aside. With the rules, what's step 1? Count all the valence electrons. So here's what I do. I put all of them here, so that's oxygen. There's 2 hydrogens. And then there's the one due to its charge. Does oxygen have a charge? Does H2O have a charge? Hands up for no. Hands up for yes. Hands up if you never vote in these things. Okay, if you never vote, by definition, right now, you would not be voting, so you lie. There's no charge here. This spot is for if there was. If this happened to be, well, first of all, let's get to that. How many valence electrons does oxygen have, please, Anton? 6. And how many valence electrons does hydrogen have, Donald? 1. And if we've got 2 hydrogens, we have 2. And then we don't have a charge, so that doesn't change it. If we had a +1 charge, how would that change? Yeah, Anton? Well, we wouldn't say oxygen because it's the whole thing, but we would put like what you're doing is you're removing. If it was +1, we'd make it -1 electron. If it was -1, that means we have an extra electron. But because we have neither of those things, I'm including it to be pedantic to show that we don't. Let me get my eraser and remove that particular charge right now. So we add it all up. We have 8 electrons. What's the next step? There's a step before that. There's no charges. Bond the atoms. Which one's the central atom? So you put oxygen down first. No. I mean, you look at it and go, which one would be the central atom? Well, there's only one atom that we only have one of. Yeah. Yeah, then it gets more complicated. Yeah. And then you have to guess harder. Yep. And then you put in your bonds. How many electrons do I take away for those 2 bonds? 4. 2 bonds, 4. So we go -4 electrons. Do this. Keep track. So as you go along, I want you keeping track. Now, at this point, the rules would say we put them on the outer atoms to give them an octet if they need it. Does hydrogen need an octet? No. Why not? Yeah, it's full at 2. It only has the s orbital, as we now know in grade 11, and so it's fine. But if it's full, then where do those electrons go? Around the central atom. So you just put it on the central atom. In pairs, always in pairs. Now, does oxygen need more, or does it think it has an octet? It has an octet, so now we're done. So that was a fairly easy one to do. We end up at the same structure. Yes. Everything wants 8 electrons. Yeah, which oxygen is one of. Oh, don't worry. We'll be doing later on all the exceptions to the octet rule. Yeah, so that'll happen. But oxygen right now, if I cover up that side and I cover up this side, how many electrons does it think it has? 2, 4, 6, 8. And I've just told you that everything obeys the octet rule except for hydrogen. That's the only exception you know. So I'm only going to give you examples that don't break the octet rule with the exception of hydrogen until we figure those out. Okay. Do exactly the same process. Count out your valence electrons. I want to see it for NH4 plus 1. Oh. And then while you're doing that, I should put the attendance on my school. Okay. There we go. So who am I missing? I was missing Martin, Will, Jonathan. Hold it. Joffrey. Anybody heard from Joffrey? Yeah, what house is he in? Oh, Mr. Gage didn't put it in. Do you know his advisor? Ah, okay, so. Now I'm going to come around and look. I want to see your little section of valence electrons, how you've minused them through, putting them on, so I want to see your work. And save. Okay, let's see your work. Minus all the way through. All the way down to 0. I just want that habit well established. And now you also have to deal with the +1 charge. So I want you to see that, and then I want you to total it up. As well, if you want, you don't have to write it separate. You could just go 4 hydrogens and go 4. Just do that. Might be unless, do you really like that? Like, does that make it clear? Okay. Erase those. And put down the charge on the left-hand side. So it's a +1. Yep. Colon. And then how does the charge change the number of electrons? Yeah, so you write -1 there and then add them all up. No. Put it like right beside it, like that, in the spot you gave for it. Yeah, draw a little line underneath it and just, yeah, add it. Yeah, oh, sorry. I mean to save room. I mean, you don't have to do this. This is perfectly fine. But you can just like, boom. And then you get your 8 there. Because you're going to continue you're going to continue using this, so you don't want to keep going. Now you did that. Erase that one. Because we don't put them on singles, however. How many hydrogens you got? 4. So you got to put them all 4 around the central atom. Yep. Excellent. Yeah, and how many electrons did you use up putting all 4 around the central atom? 8. So minus those 8. Yeah. So that means you have no more left. Make sure everybody's happy with their version of the octet rule or exceptions. This is NH4. You've done NH3. How'd you get 3 electrons from 4 hydrogens? Oh, no. Do that separately down below. I want it very explicit. Because the electrons don't come from one atom in particular. And you're missing a hydrogen, so I'll come back. You are also missing a hydrogen. No, like there's 4 hydrogens. You've only got 3. Oh, you can't just not write it. How many siblings do you have in your family? Oh, there's just 1 of you? Or is there 2 of you? I'm going for an analogy here. 1 or 2. There's 2 of us. So you don't just say, oh, we don't have room for one of them. We'll leave them behind. No, you don't do that. Even if you got to strap them to the roof, you take them with you. You've got to put all 4 down. Does the analogy work? No, you got to put it around the central atom. Where'd you write down the rules? Excellent. You should be referring to those. So, okay. Now you draw each with 1 bond. Is this due to is that 11? Yeah. Why? How many valence electrons does nitrogen have? As well, put the plus or minus, put plus 1 below it. Because you don't want to add them here. You want to also now deal with the charge. Oh, I want you to set it up like the other one. So you've done it. You don't put those little 2s around. Just because the final, unless you redraw it without it, that's fine too. And this is not a bad way to do it. However, what I want you, since you were in the washroom, this is the danger with going to the washroom. I want you to add up all the valence electrons like this. So put the parts of them, so oxygen, 2 hydrogens, and then deal with the charge. So can you set it up like that? Maybe on a fresh page? And I'll just continue walking around and just look at everybody else's as you do that. Let me show you. 5, 4. You add 1. Why did you add 1? Oh, no, I don't want you doing this. This is the other method. I don't want you doing that at all. I want you to only do this. And then due to the charge, what is the charge? It's plus 1. So instead of writing plus minus, just write plus 1 there. Like right here. Okay? Okay, and then colon. And then what does that do to the electrons? Yeah, so put minus 1 there. And then add it all up. What's 5 plus 4 minus 1? There you go. Now put down the central atom and connect the other ones to the central atom. You have the setup correct. Five. Oh, no. So instead of going plus minus, go plus 1 right there. And then semicolon. And then what do you do to the electrons in that spot? Yeah, so put minus 1 there. And then that way keep this 5, 4, and minus 1. Yeah, so you don't have to go 9 minus 1. It should just be 8. So just to show everyone how to set it up, we would have nitrogen. We'd have 4 hydrogens. And here we wouldn't put plus minus because we actually have a charge. We would put it is plus 1. Nitrogen has 5 valence electrons. 4 hydrogens has 4. And what do we do to the valence electrons if we have a plus 1 charge? We subtract 1. So you just put minus 1 here. So this, always just put the actual charge there. And then you just, how I remember is I just opposite the sign. So if I have a +1 charge, I have a -1 on that side. If I have a -2 on this side, then I should have +2 on that side. Add them all up. So in terms of the setup, I want to see this every time. This will help out with the more complicated ones, particularly later on and when we get into valence shell electron repulsion theory. Because coming up with some of those models can be a little different. Put the central atom in the middle. What's the central atom in this case? Nitrogen. And then the outermost ones, equidistant around it. Bond it. How many electrons do you take away with 4 bonds? 8. So I've got 4 bonds here, 2, 4, 6, 8, minus 8 electrons. We're down to 0. I want to see this accounting as well. I want you to account for your electrons, because at that point you know you have no electrons left. And then we would check, are all the hydrogens happy? Yeah. Does nitrogen have an octet? 2, 4, 6, 8. Yeah. So this is our final diagram. Looks like I drew it a little bit messy. I could fix it right there, and that looks a little smudgy. Make it nice and straight. But now we have a nice Lewis dot diagram for NH4+. If I wanted to get really fancy and show people that it has a +1 charge, I'd go like that, just to say that the whole thing has a +1 charge. So that is how you deal with a charge. Do the same accounting procedure, and let's do CO2. Hold it. Does anybody need this on the board for longer? No, we're all good. Okay, CO2. You okay? Okay. Can you flip to your back page? I just want to see the previous one. Oh, there it is. Excellent. You've got your accounting. From S2, you've got your accounting. Excellent. Where's your NH? I'm just trying to find your accounting. Yep, there we go. You wouldn't put on dots yet. Well, you would, but only in pairs. So how many do you have left to get rid of? Yeah, so put them on in pairs on the outer ones first. Not the central atom. You go from the outer in. The outer rim planets get dealt with first. Excellent. Central atom in the middle. Put the outer, other ones around it. No. Central atom in the middle. You put the other ones around it. So don't start making Lewis dot diagrams. Yeah, and then bond them and minus your electrons. Oh, it's easier than that. Which one are you trying to count? So the method I taught last year that you learned is the same. Even with all of that, it's still the same. Just last year, for the reason. So you always just count across, skipping the D. So how many does carbon have? 4. How many does phosphorus have? 5. How many does sulfur have? And gallium? 3. That's all you need to do. So carbon has 4, and then oxygen, but you have 2 of them, so oxygen has 12 for, yeah, 6 times 2 total. Yeah, so do it that way. How are you doing? Oh, no, 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 no. I mean, fine, but go to a new page. Give yourself some room to spread out. I want you to also stop writing Lewis dot diagrams for all the individual atoms. You're not allowed to do that anymore. Yeah. So write down the... so start off like this, Keith. Write carbon, 2 oxygens, and I'll put an X there because they're oxygens. And then our charge is 0, so we don't have to worry about that. So write down the valence electrons for carbon and the valence electrons for 2 oxygens. Excellent. Now draw a line and add them up. Yeah. Excellent. Now, which is the central atom? Carbon. So give yourself some space. Put down carbon in the middle. And then put oxygen around it. Yeah. Now notice we're not making Lewis dot diagrams yet at all. We're just sort of... Oh, no, no. What are you doing? That was perfect. No. What I was saying is notice we're not making individual Lewis dot diagrams. Now you bond everything to the central atom. How many electrons did you use up? Minus those 4. Now flip back to the rules. We did up to bond atoms to the central atom with 1 bond each, and we removed ours. So what's the next step? Do you start with oxygen or carbon? No, central last. That's okay. Only in pairs. Just start giving them electrons in pairs until their octet is full. Yeah, and how many did you use up? 6 minus those 6. Oh, yeah, you could do it on the other side until they have an octet. But make sure you minus them. So you have no more electrons. You cannot add any more electrons. Are they all happy? Who's unhappy? Right, what are you going to do with that? How can it get more electrons? Look at step 4. How's yours looking? If you're going to pick a method, hold it. What are these? Where'd those pairs come from? Where did it get them from, though? Like, how would you give it to them? Yeah? No. It doesn't have 6. You have a total of 16. Erase everything but the lines joining carbon to oxygen, because you also haven't done your accounting here. So you haven't accounted for those, so we have to start over again. Excellent. Now, how many electrons have you used up? No. In here. How many are in those bonds? In these bonds? How many electrons per bond? 2. You've got 2 bonds, so how many electrons? So you minus those 4. You go underneath it, minus 4. No, minus 4. Yeah, because it's not negative 16. What? Erase the plus 4 for a second. I want to know where you got that 16 from. Right. So it's not minus 16, it's just 16, right? So erase this underneath so we have a nice clear page to work with. And so that's how many electrons you have, right, to work with. You used up 4 of them in here. So underneath that you go minus 4 to show that you've already used up 4. And then how many do you have left? 12. So put a line, write 12. Excellent. So now you got 12 electrons left. So you've bonded it to the central atom. The next step is to give every atom an octet using these electrons until you run out, starting with the outer atoms. So start putting them on in pairs. And just don't go over 12. Excellent. Did you use up all 12? Yes. Minus the 12. And what do you get? Excellent. You are out of electrons. You cannot do anything else. Are they all happy? Do they all have an octet? No. Who doesn't? Carbon. So look at step 4. What do you do when they don't have when the central atom doesn't have an octet? Oh yeah. Step 4. Look at step 4. What do you got? Hold it. Why do you have lone pair electrons around? And yeah. Okay, you didn't. It didn't look like you kept accounting here, so I want you to do accounting. Erase everything except for these 2 lines. Yeah, erase the dots on the top and the bottom, and just go carbon and then a single bond to oxygen on each side, because there you had everything, right? How many electrons have you used up? Minus those 4? Excellent. Now, what's step 3? No, central last. So put them on in pairs around the outermost atoms. Yep. But you can just start with 1 pair. Give it a full octet. Like one of the oxygens, give it a full octet. You've got more than enough electrons. You just keep going to an octet. Good. How many have you used up? Or maybe erase that one. Focus on this one. How many electrons did you use up? Minus 6. What do you got left? Right. Go do the other side. Okay, how many did you use up? Minus those 6. Excellent. So now you can't add any more electrons. Are all the atoms in there happy? No, they're not. Carbon. Carbon's sad. Read step 4 for what to do with carbon. Yep. Yeah. Yeah, those ones. Yeah. Yeah. Nope. You have not done. Okay. 4. What's 4 plus 12? Right. Get that in there. And then the next step, bond the atoms to the central band with 1 bond each. How many electrons did you use up? Minus for those 4. Right. Excellent. Now you've got 12. What's step 3? Yeah, so don't do the central. Add electrons to the oxygen until it has an octet. It has an octet minus those 6. Excellent. Now do the same on the other side, yeah. Excellent. Now that is the next step is step 4. What do you do? Because are they all happy now? Carbon's alone. It doesn't have enough. Carbon's there. Please, sir, may I have some more? And so what would oxygen do as its very good buddy? Yeah. What? Why are you adding extra oxygens? There's only 2 oxygens. You're just stealing oxygens. Erase that entirely. What are you doing? Crazy. You only have, those are its only friends. So carbon is like, please, I need some electrons. Who can I get electrons from? Right. And what does step 4 say you can do with those electrons? Yeah. Think where those electrons could go. Show me what you mean. Oh, no, 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 no. They stayed together. Show me what you mean. Oh, very good. But then you should probably put it like in there with the other one. Like, if you're going to make it a bond, you should probably put it in there where the bonds go. Oh, yeah, but you don't have to put it there. Put it like right in the middle where the other one is. Yeah, now you got a double bond. So you took those electrons away and you put them in there. Yeah, yeah. Whoa. That's really, yeah, don't do that. Erase those. You don't mean to do that? No, excellent. Okay, those 4, and you had 12, right? Step 3, what's step 3? Oh, you put them on the outside atoms first. Give oxygen an octet. No, just do it. Just give it an octet. In pairs, put electrons on it till it has an octet. Just give it a pair of electrons. Yeah. Oh, it's closer to an octet. No. You started with that one. Keep going. Hold it. No. It only has 4. Oh, it's closer. Keep going. Oh, not down. Oh, that's crazy sauce. Where's the blank spot? There. Now, does the oxygen have an octet? Yes. How many electrons did you use up to do that? 6 minus those 6. Yeah. Now you can't. You'd central last. So do. Yeah. You minus those 6. You're out of electrons. Yep. SOL. No electrons left. No electrons left. You've accounted for all of them. Are all the atoms happy? No. So what's step 4? Look at carbon. Where's its neighbors? No, right there. Where's its neighbors? There. Yeah. Those are its neighbors. Carbon's there. I don't have enough electrons. There's a way you can give it in which they don't give it away. You know who knows? Kate knows. You could go ask Kate. Kate knows. Yes? Yep. Because I told you bond the atoms to the central atom. You don't bond them to each other. You just don't do that. Okay, stop that. Stop that. Excellent. Now, hello, Mr. Lee. This is good. Now, step 3. Step 3. Okay, just look at me. Forget the notes. Give the outermost atoms an octet. So pick one of the oxygen. Which is your favorite oxygen? Give it an octet because you like it the best. 8 electrons total. Yeah. How many sides does an octagon have? 8. So octet means just 8 electrons. So it now has, oh, no. You gave it 2, 4, 6, 8, 10. That bond is already 2. Can you erase? Because that's going to get confusing. Is there anybody else who needs help? Kate? Do you know what you're doing now? Who else needs help? Sasha, go help Ned. No. Sasha, go help Ned. No. If you got it, go help. Good. Go help Ned. Go help Ned. I will help you after you help Ned. Go help Ned. Do you? Okay. Excellent. How many electrons did you use up? No. How many did you put on? Count them. Yeah, so minus those 6. Yeah, because this is just keeping track of how many you've used up. So you minused 4 because you had them in bonds. Now you added 6 to give it an octet, so you minus those 6. We're just keeping track of our electrons. So we have 6 left. And it says do the outer atoms first. So now do that one. Minus it, because we're just keeping track. We have no electrons left. So we've gotten to 0. That means we can't add anything. So this is a good space to be, because now we can see this. We've got the right amount of electrons. Is oxygen happy? Is that oxygen happy? Is carbon happy? Is it? Does carbon have an octet? No. How many does it have? No. Well, how do you get 6? No, wait. You just drew those. It didn't have them. You just gave it to them. Do you just give away all your money? Like you just walk around and you just start giving it away? No. Don't do that. Carbon, how many does it have right now? It has 2 bonds. So 4 electrons, yeah. So 2 bonds, 4 electrons. Because what you're doing, I think, in your head is you're going like carbon has this many, and I want to get it. No, we're not doing that anymore. You're following a process. You only has those 2, so it's not happy. It needs 2 more. Where could it get some? Yeah. How would you give it some from oxygen? Yeah, do that. How would you do that? Oh, no. Because oxygen's happy the way it is. It's not going to give it away entirely. No, you've only got 2. It's CO2, not CO3. Pardon? Oh, Sasha, come. Help. Where? Yeah, looks good. Yeah. Yours good? What? Yours looks good. Nope. Erase all the blue. Oh, no. Hold it. You're good. You're just not quite all the way there. So, step... No. Put it back. Put it back. Yeah, and then I said no. And you didn't hear that part, so it's fine. So, you have those... You have it there. Oxygen's happy, right? Carbon's not happy? Yeah. Right. So, how could carbon get some more? Yeah. What's its neighboring atoms? Who are carbon's neighbors right now? Yeah. So carbon's like, I have no food in my bowl. Oxygen says, hey, I'll help. How can oxygen help? Yeah, do that. So redraw it or do what you need to do to show that, because I need to see the final one to make sure. Whoa. No, that was a lot of erasing there. Yeah, there you go. That's it. Nicely done. Da-da-ba. I'm skipping over your thing. No, you added oxygen atoms. Why'd you add oxygen atoms? Yeah. No. 2. It did. Show me where it says add more atoms. Give another bond. Yeah? So I added more bonds. No, you didn't. You added more atoms and more bonds. Isn't that the same thing? No, because this is CO2, not CO4. You can't add more atoms. So how can you still add those bonds with the atoms you have? Well, is oxygen happy? Yes. Yeah, carbon is not. So oxygen is going to be a good neighbor. Ehunde, do you understand? Oh, Sasha. Oh, excellent. Come here. Come here. Help. Help Evan. Yeah. Do it, redraw it, and show me what you got. Like erase or do whatever. What would that look like in its final form? Oh, no, not with a... You don't draw... When you have a bond, you just draw a line. Yeah, get rid of the little circular thing. And then put in the electrons that are still left. Well, where did that line come from? You use those two electrons, right? So how many pairs are left? What? There's that pair and that pair. So you'll use those two electrons to make a bond. And I'm assuming you used another two on this side to make that bond. So once you use up, how many pairs are left? There's two pairs there. You see what I mean? Yeah, so you still have those two pairs left on all the oxygens. Yeah. Evan, does that make sense? Excellent. There's something wrong with that. Yeah. Yeah. Do you know what you did wrong? And you've got it now? What did Mr. Lee want? Oh, to another, yeah, after spring break. Okay. Is there anybody who still has another question? Yes. 1 second. Hello. Yes? I'll quickly do it on the board, and then we'll see if that solves it. I think I saw yours, and I think you did, but let's check. Okay. Although I could send Sasha to you. What? Okay. That was a little strong. Okay, carbon has how many valence electrons? And 2 oxygens has. And then 4 plus 12 is. Excellent. Then we put carbon in the middle. Oxygen on either side. 1 bond each. We minus 2, 4 electrons. We have 12 electrons. And then I start putting on the lone pairs to make an octet on the outer first. Outer first. 1, 2, 3, 4, 5, 6. Minus 6. 6 electrons. 1, 2, 3, 4, 5, 6. Minus 6 electrons. Oh no! There isn't enough to go in the central atom. So when it says borrow a pair from the neighbors are the ones right here, because carbon's like, I'd love some more. So you take these, and they become bonds. Like that. Now, is carbon happy now? Needs another one. Now, we don't give it from the same one. We do it symmetrically. So we get it from here. We're like, whoa. But we don't keep them as two dots either, because once they're in bonds, we have to draw them as a straight line. Now, I see enough, and many of you have apparently turned German. A lot of people were doing this, and this is perfectly fine, because you can also represent lone pairs by lines like that. Either one of those is fine. I don't care. Now, this is the correct Lewis dot diagram. Now, sometimes students they get carried away, and they do this. They go, oh, yeah, I need more bonds. Yeah, what you can have a triple bond if we require it. You know what you can't have? A quadruple bond. And I have seen this. And somebody in this class will do this because for some reason, it's easy to get carried away. I don't know why. So we'll just see on the next test, like, who's going to do this. And they'll keep going. But why is this wrong? Is oxygen happy? Sure it is. 2, 4, 6, 8. Oxygen has 8 electrons. It's fine. Yeah, but carbon has 16, and that's why carbon's like, it's been enough slices. It doesn't want any more. So we'll put them all back. Whoops. Go a little farther. So that's why you stop there, because carbon's finally done. Just so you're aware, in case you ever have it, a quadruple bond is actually impossible. A quadruple bond, pardon? Oh, because there are exceptions to the octet rule. Yeah, you could have Like phosphorus, I've told you so far that everything obeys the octet rule, but like phosphorus is a lie. It doesn't. You can put 6 bonds on phosphorus and it will have a 12 electron rule because it has access to the d electrons. And the reason they don't go together, regardless of how the math works, apologies. Let's pretend that we have something like this, okay, like that. And yeah. No? Is this class over? Hold it. What time does the bell go? They're just so good. Oh, it ends in like 30. Ah, whoa. Before you go. No, don't go yet. These are for homework. But not all of these. These are for homework. I would like you to attempt these for homework. We will go over them and have a chance to do them also next day. But I would like you to do these for, once you have this written down, you may go. Thank you very much. It's also being recorded for those who are taking pictures. This is streaming live. Woohoo! Oh. They just love the way I speak. Running around. Are you covering for Miss Hampton? Yeah. Okay. Yeah, she normally comes in after this. That is true. No, all good.